Hello students, today I am going to cover up hardware locks, semaphore and monitors. The basic concept how these works. So firstly coming on the hardware synchronization. Software synchronization proposed till yet have the guarantee to work on the modern computer architecture. Now hardware level solution propose the handle to handle the critical section problem. All these solutions are based on premises of lock that protecting of the critical region using the lock. The design of such locks can be quite sophisticated. Now, as we know that it is basically locks as the hardware level interaction. So hardware level interaction is very fast and guarantees that only one process can enter into the critical section. So how it works, let us see. Again, like the software solution, it will has a entry section. As it enters into the entry section, it will disable the interrupt and then after enter into the critical section so that no other process can interrupt it. When there is no interruption, it will continue its execution, and when it will come after completion of the part that it has to execute in the critical section, it will come out from the critical section. As it is leaving from the critical section, it will enable the interrupt so that other process can allow to enter into the critical section. It will work fine for the uniprocessor system, but in case of multiprocessor system, means a system that has more than processor, it will difficult to manage the locks uh, or the synchronization of the lock. It is also difficult if a processor has multiple cores. So each core itself works as a CPU. So how the lock will be managed, it will be a difficult process. So it is efficient if it is a uniprocessor system and more efficient than the software locks. Now, how the process execution take place? Suppose that process A, there is no process in the critical section and there comes a process A and that want to enter into the critical section. So it will create a lock and then after it will allow to enter into the critical section. Mean this is this process enters at the time t1. Suppose that at the time t2 process B arrives. Now it try to check the lock. The lock has disabled. The lock is enabled, so this process cannot enter into the critical section. But it continuously check whether the lock is disabled or not. So after checking the lock, continuously checking the lock, when it finds now the lock is open, when lock will open, when the process A leaves the section. So when the process A leaves the critical region, so it will enable or accept, allowed to accept the another process to enter into the critical section. So at the time T3, B can and process B can enter into the critical section and it will again lock disable the interrupt so that no other process can interrupt it when it is in the critical section, and then after completion of the entire process it will again re-enable the interrupt so that other process can allow to enter into the critical section. How will it take place? Let us see. Initially lock will have the value 0. It will check what is the actual value of lock. Okay, so if 0 is not equal to 0, the condition will get false. A process will enter into the critical section. It will, before entering into the critical section, it will set the value of lock as 1. And after completion, the critical section portion, it will again set the value of lock as 0 and execute in the remainder section. Now, this is the one process I have explained as given in the book. Now, I am taking the example with the two process. Suppose that there are two process. P1 and P2, initially the value of lock is equal to 0. Now, what will happen? When a process P1 want to enter into the critical section, it will check the value of lock. Lock is 0. 0 is not equal to 0. The condition is true. It will enter into the critical section. It will set the value of lock 1 and allow to execute in the critical section. Now, when a process B or P2 arrives, it will check the value of lock. Now, at present, the value of lock is equal to the 1. 1. So, it cannot, it 1 is not equal to 0. Condition will get true and it will be in the infinite loop. When this process leaves the critical section, it will set the log value as 0 again. Now, 0 is not equal to 0, condition get false. Now, this process can enter into the critical section. It seems everything is working fine, but there may be a problem. What problem will be there? Let us see and discuss it, how the problem arises and how to resolve that problem. So, here, suppose that there is a switch overing from the process P1 to P2 or the process 1 to 2 after the state executing of the statement 1. That means it will set the value of, it will check the value lock is equal to 0. Yes, it is true. And meanwhile, the switch over of the process has been taken place. Now, the process 2 or the process P2 will check whether the condition of the lock is 0 or not. Yes, it is still 0. So, it will check condition and try to enter into the critical section. Meanwhile, there is a switchover. So process after switchovering the processor, the process 1 will set the value of lock is equal to 1, and meanwhile there is again a switchover. So this process 2 is also setting the value of lock is equal to 1. Now both process has set the value lock is equal to 1. Then after there is a switch overing, it will enter into the critical section, and then after certain time of interval there is switch overing. This process will also enter into the critical section. So two processes simultaneously inside the critical section. This should not be there. That means it is violating the condition of the mutual exclusion. So what should I do? To overcome from this, there is a solution. We should make these two statements as atomic. What do you mean by atomic? Atomic means either none of the statement will get executed or both executed simultaneously. So this is the solution. So while lock is not equal to 0, it will check initially lock value is equal to 0 as we have discussed in the previous slide. So lock is equal to 0. Now until it will not set the value of lock is equal to 1, it cannot switch over from process 1 to process 2. Now it will set the value of lock is equal to 1, and then after when it will get switch over, so it will check what is the value of lock. Lock is now 1. Lock value has the 1. So sorry, it is 0. Log value is 1. 1 is not equal to 0. The condition will get true and it will wait for the infinite loop. Thus, this solution allows us only one process can enter into the critical section. That means it will satisfy the condition of the mutual exclusion. No two or more processes can enter into the critical section simultaneously. Now, mutual exclusion. Mutual exclusion basically is a condition that is used to allow a process into the critical section. Only a single process allows to enter into the critical section. Basically, it is used for threads and it is just like the lock. It has two methods, acquire and release. Before entering into the critical section, it will acquire the lock and then after when it is leaving the critical section, it will release the lock. So there are two functions as discussed. So whenever a process want to enter into the critical section, it will acquire lock, will execute. In acquire lock, it will wait, it will check for the whether the lock is available or not. If not available, it will wait for the infinite of amount of time until the available will not get will not be available. So this condition is known as the busy waiting. And when if it is available, so that means condition is true. So it will set the available is equal to false and enter into the critical section. And when it is coming out from the critical section, it will release the lock. So it will set the value of available is equal to true. So this is the procedure how the mutex works. Initially, the mutex value is the true, and then after uh, true means a process can enter into the critical section. True means 1, not equal to 1, not equal to 1. This condition when will get false, so it will enter into the it will set in the availability is equal to false and enter into the critical section. Now, semaphore. Semaphore is suggested by the discussed. It has two functions that are known as the down and up, sometimes known as the sleep and wake up. Semaphore has two values, either 0 or 1. Especially, it is the special case, 0 and 1 is the special case of semaphore that is known as the binary semaphore. In general, semaphore have any positive value, that means 0 to any natural number. But in case of binary semaphore, it will have only two value, either 0 or 1. The semaphore s is an integer variable. Apart from initializing, it exists only through the standard atomic operation wait and signal. These operations are uh, defined by the discussor, Mr. Discussor, and wait op wait operation was generally termed as P, and signal operation is generally termed as V. Initially, it is a shortcut. Basically, Verwogen means increment. It is a Dutch pronunciation. So there are two operations, increment and decrement. So wait will check for the condition and signal will increment the value. So how will it works? Let us see. Signal. Firstly, it will check for the condition whether the value is less than equal to 1 or not. Suppose that initially the value of semaphore S is equal to 1 and someone want to acquire the lock, so it will set the value as 0. That means 1 is not equal to 0. Condition get 1 is not 1 is less than equal to 0. This condition will get false, so it will automatically decrement the value of s as s minus minus. Now, when this will be 0, now if another process want to enter into the critical section, this condition will get satisfied. 0 is less than equal to 0, so that cannot be enter into the critical section. While leaving a process from the critical section, it will set increase the value of s by 1, s plus plus. So now another process can enter into the critical section. So semaphore s is a shared variable that allows to enter one process into the critical section. So we can generalize information. We can have, suppose that we have a trial room that has a, we have trial rooms, basically four trial rooms. In the initially beginning, each trial room is empty and there is a lock in the trial room. If a person want to enter into the trial room, it will pick up the key that are hanging at one place and enter into the critical section. Suppose a second person comes for the trialing or for the want to go into the changing room, so it will again pick up the key and enter into the critical section. So initially semaphore has value 4. These are the trial room value, or we can say key value. Each time it is decremented by 1. When it is equal to 0, so no one is allowed into the critical section. That means trial rule. So semaphore basically works as a counting variable also. Now, the last portion is known as the monitors. Monitors basically a concept of the object-oriented programming. In this, the function and variables are combined together inside the class. It is just like a object oriented, as I have said, it is a object concept of object oriented programming. So class or the monitor basically combine these two things. And a outside if a outsider want to access these, so it should firstly go through the procedure, and then after procedure will allow to access the local variable. The monitor is one type of the way to achieve the process synchronization. The monitor supports by the programming languages to achieve the mutual exclusion. It is an abstract data type, means it hides the variables whatever the inside the class or the monitor itself. So here a process want to access the shared variable. Firstly, it will request to the procedure, and then after procedure will check whether it is a procedure will check the shared variable value. If it is allowed it to enter into the critical sections, that means no other process is executing in the critical section, it will be allowed it. Otherwise it will be blocked. Suppose that process 1 is executing the shared variable and process 2 want to enter into the use the shared variable, it will get blocked. When the process 1 release the shared variable, then after the process 2 will be allowed it to access the shared variable. So this is the concept that is used by the monitor. Now, so monitor can access the shared variable using the wait and signal function. So wait function basically decrease the shared variable value as in the semaphore s minus minus, and when it is releasing the critical section, it will increment the value so that another process can enter into the critical section. So this is the basic concept of the monitor. This is from my side. Thank you.